Hello, everybody. Welcome to Leni Talks. Today we are here with Gustavo, and we will be talking about Godot and Godot shaders specifically. And Godot is a free game engine, right? Open source to the community, so everybody can use it for free and also contribute into its development. Since this month is game dev month, actually here at Lenio. This is a pretty important topic because we will be learning one of the pillars in game development to make our games look cooler than we can make them look in just 48 hours. So this is a key feature that we actually maybe are going to use in the following game jam. So thank you, Gustavo, and you can continue.
Great. Thanks, everybody. Good morning, good evening, good afternoon, wherever you are. I'm Gustavo, Python developer at Leni. Almost basically my first anniversary here at the company. It's very exciting and cool. Love being here since the first day. So today I'm going to talk about shaders and use them with Godot. I know you guys basically asked me about some tutorials with Godot beginners, but yeah, I had this crazy idea in mind that maybe we just start like familiarizing with the UI and the Godot engine. So I think it's a pretty good start just to be able to see shaders with Godot. And it for me was basically like a topic, a difficult topic on the first time I heard of shaders. And yeah, I will gonna try to at least give you some idea of what shaders are. So what to expect in this talk? Well, shaders, first of all, shaders is a massive subject. So it's really vast in the sense of information that you can basically find a lot of information out there. So today we're just going to scratch the surface a little bit with shaders. I promise just to keep things simple as possible, just to be able to understand some of the key aspects of the shaders in Godot. And yeah, one of our main goals here is just to give you a little taste about the basics and shaders and the fundamentals of shaders. So and how can easily you can code them and using Godot. Yeah? So and maybe you use them on the game engine, on the games you will be developing. And yeah, and start like you start experimenting on your own. And yeah, I will just trying to use that as your personal playground, call it as your personal playground of shaders. And yeah, so let's a little story of background. I can remember some years ago when I was like more active, really developing games with Unity, and I was on a dev group, on a chat dev group. I think it was Discord. Yes, it was in a Discord chat. Yeah, the guys there really talk about different topics, level design, coding, optimization, sort of that the topics that were discussed there. But yeah, there was this guy always mentioned, hey, you should use shaders. So shaders? Oh, but that sounds interesting. Okay, gonna take a look. So yeah, the first time, okay, I open up I booted up my workspace and open up Unity. And yeah, I was like, okay, shaders. We have some information here, there, some like exchange like terminology. Okay, we have color, vector, cube, something like I was like, okay.
Me meten abajo los pies.
Exactly. I have no idea what I was doing. I felt overwhelmed by a lot of quantity of stuff that that Unity has behind the shaders. So it basically discouraged me to even consider in the first place to use them on my games. I was just at the time more focused on this was a little game I was developing at the time. And obviously I was just struggling just to make the animation enter the right in the right frame when you jump the maximum when you get the maximum height of the ship in this case. Yeah, I was just struggling with that, and shaders was out of the question. But yeah, it's not obviously Unity's fault, because basically I needed like the basic understanding and the basic theory about shaders, because it's related to computer graphics theory, and mostly how do I say, it's a broad term, like a category of computer graphics. So I need that theory first, so I need to study. So it wasn't just like 2 or 3 years ago that I started looking on Godot, and I obviously know a little bit more. So the first thing that you might want to know is what a shader is. Yeah. So the basic, like the most broad concept, or what it means to be what it means a shader is. So what a shader is. Shaders can be a lot of things. So because they are very, like I said, it's a broad category on computer graphic techniques, because they can use to achieve a lot of wide range of visual effects. So which visual effects do you ask? Well, it's basically all the effects. You have light, shadows, diffuse, specular, lightning, reflections, refractions, texturing effects, post-processing effects. So depth of fields, when you have the sort of camera effects, that depth of field from the camera, the angles, water simulation, fog. So it's everywhere. Maybe it's so yep, it's a vastly subject, obviously. But yeah, the only thing that maybe is where should we use it? No, everywhere. We're using everywhere shaders on the game engine. But okay, I just tell you what our shaders are, but they use when we use the shaders. But what is a shader? A shader, it's still the question that drives here, that drives you here. Shader is a special kind of program, so that runs on the GPU, on the computer graphics card. In the case of Godot or any other engine that you might be using, basically you can use them to control how the engine draws the geometry and the colors of the pixels on the screen. That's just the basic, like the definition of shader, what a shader is. Yeah. So and obviously they allow us to achieve all kind of visual effects. So, because of this, like kind of nature that they throw on the graphics card, they have like 2 important keys aspects of in this case of what the shaders are, because they are all executed all at once. Yes, on every pixel and on every vertex of the object that is drawing directly on the screen. Yes. So more of this in a few minutes. Because of this parallel nature, obviously, they don't process information the way as the normal program typically do. You cannot store data between frames. It's kind of stateless in that sense, because you can access the frame before or the frame after, It's just like if you have this input, okay, and you will be having these outputs, the specific output. So you need to like code like things differently from what are typical programs or procedural programs as we know it. So, but the other key aspect is that shaders are not your normal programs. That's for sure. So let's see an example. You have here, so the base, so in a normal situation, let's say you have a grid, maybe a HTML grid. Obviously, if you guys know CSS, you could just set a selector, and yeah, obviously from there you could, okay, start from like, obviously with CSS selector right away, like change the color. But let's say you have to change that color procedurally with code. So yeah, you have a grid of squares. Maybe they are like this already green color. They are the color, but we not to set it that it is purple color, right? So well, the normal approach will be to make a nested for loop or a for each loop and traverse all around or iterate all around every single grid or every single square and set the color for that, obviously all the squares, right? And that's the normal situation. But what happens on shaders? Shaders, it's like kind of different. Imagine that now we don't have the grid with the squares, but pixels. No, you have to think in pixels of the object, right? So, like said, this is a snippet of a shader, how a shader looks. It's basically that for loop that we saw before. This part of the code, like this on the side of the second for loop, is like implicit on the shader. So this will run basically on all fixes on the object that you are trying to change or trying to modify. So this is the equivalent code for the shader. And more of this, I will be talking about the fragment function a little bit. So what are basically doing is here, okay, just set the color. I like declare like a vector object, and in every single coordinate, I set the right amount of RGB, in this case, the red channel, the green channel, the blue channel, and the alpha channel in this case, but I just change the color this way. So yeah, that's basically what we like how the shaders are in code. Shaders in Godot always really are a little bit easier to manipulate because they provide a simplified shading language based on popular OpenGL shading language in this case. So you can go here, for example, and see on the documentation, okay, introduction the shading language is similar to the GLSL SLS3. You have most data types and functions that are supported. Obviously, on a normal program, you have bools, you have like floats, you have other types of, obviously, like mathematics stuff. You have vectors, you have like matrices, all of that. You have samplers. Samplers is my kind of like a special kind of like type that basically is related to the textures, to the images. So it will be helpful to just to obviously to draw the shader on the screen. You have obviously like some like features, and you have arrays, you have all of it. So you have basically most of the types that you are familiar with. But in a little bit, you will see that there are some like variables that are almost overwritable and others are not like overwritables, just read only, and that will help you to like, okay, construct a shader in the sense. But yeah, that's basically what I wanted to show you here. And yeah, we have float, we have map functions, and the syntax that shaders on Godot, the syntax is very similar to C. C syntax because it's obviously, as I said, it's based on this OpenGL shading language, and it's pretty cool, very easy to follow. Yeah, so shaders in Godot are like, we have like 5 types, different types of shaders. We have canvas, item, spatial. Canvas item is mostly for 2D nodes or 3D objects. Spatial, obviously, for 3D objects. Particle is like those familiar with particle emissions on the engines. It's obviously related to those. The sky generation, obviously in the environment around maybe a 3D environment, the sky, and fog. Yes. And obviously, every kind of type of shader type doesn't have all the access for all the processor function we see here on the left. So yes, obviously, just the two, like the first two, canvas item and spatial, have access to these 3: vertex, fragment, and light. Obviously, particles are not, can access the vertex and fragment. It's different kind of obviously geometry involved and logic, so that they don't obviously have access to all of the processor functions. In this talk, obviously, I will focus on this 4, basically, because yeah, it's mostly, if you can, guys, like master this basic like vertex and fragment processor functions and the variables that you obviously gonna use here, you will be like understanding all like 90% of the shaders in this case. So that's why we just will be focusing on this 4 right here. And yeah, let's start with vertex. Vertex is obviously the processor function. It's called once every vertex in the spatial and canvas item shaders, right? So let's say you have like a cube, yes? So you have on a cube, on a mesh cube, you have the mesh, and the mesh obviously has 8 vertices, and in a like image, like the 3D image, obviously you have only 4 vertices in this case. And yeah, all that you do here inside the vertex function, and you will be like doing in every, we will run in every single vertex at once. That's for sure. And here we're gonna introduce these frames. We have vertex that like the built-in variable on Godot, time, and sine and cosine functions, just to be able to do some stuff with it. And yeah, let's open it up. First thing, well, if you have, are we using this like the stable edition? You can go with just here to like if you open Godot, will be prompted with this project manager right here. And yeah, you can always, obviously you can use a new project, you can set up the name of that, but I already have a project already created. So let's say we want to edit it, and just to start. Now, here, okay. So the first thing that we presented with the 3D by default, 3D environment, but we're gonna start looking at the 2D first, make it easier. So the first, like, how? So what do I do to start using shaders. But when you open up Godot, Godot provides you with like this PNG by default. You can use that just to start working on shaders. If you drag on the scene, you will see that you have like a little icon with the mascot, the Godot mascot. And yeah, obviously it's a sprite that's added to the scene. And we have here that this sprite like node has a texture, right? Okay, it's obviously yeah, just assign it to that sprite node. But from here, you will be going to this like section on the canvas item on the right, on the inspector tab. You go to material, then you set it up a material. So you have two like two basic type of materials. You have a canvas item material that it's not the normal canvas item that you set up on most objects, but you have this right here. Can you guys see that this other? I think it's a little bit short, but I don't see if the font looks okay. Here, okay, share. So when you click there, okay, you added some material, but okay, there's nothing happening. So because you need to open like this here, oh, you will be like show more options, right? From here, you can always like be like seeing this shader and the slot here, and you go here and add a new shader like this. And obviously nothing happening yet, but okay, I have the material and the shader, but okay, nothing's happening. It's because you need to click right here, and you will be show this like text editor right here. This is where we start coding shaders, right? So the first thing that Godot shows is that, hey, it's an error. You need expected shader type. Remember the shader types I talked about earlier? We need to set or establish or like declare what type of shader are we gonna write. In this case, we just write shader type like this. We start with canvas because we were working in 2D. So this is the type of shader one. Yeah, this is the first line you always have to write on the shader code. Yes, I'm good. So from here, okay, now set up the canvas item, no error whatsoever. But the things that, okay, I will want to like use the vertex function. So you declare like this, void, we call vertex like this. And from here, that is basically all of them. You need to write, like to set up all the code that you need to run on every vertex. So the first thing that we're gonna use is the vertex built-in variable, right? We're gonna manipulate the vertex variable. So let's say I want to like move offset the texture a little bit. In this case, the 4 vertices like offset a little bit to the right. So we use a vector 2 like this and move let's say, I don't know, like 15 on the right, on the x-axis, and 15 on the y-axis. Let's see. And semicolon. See, we are basically just overriding the vertex, like just to maybe moving like apart 15 pixels away from the origin, in this case, like in 15 units. So that's basically what we're doing right now. So we can just like, okay, we can just maybe no, I want to move it like 15 on the right. Okay, we have like this. Remember that this is happening with all the vertices, all 4 vertices of the texture. In this case, of the object, on the picture. In this case, that's why you see that the image is moving away this amount of units in this case. And you have maybe here, maybe 30. Yeah, that's basically what we use. But let's say I want to like add more like dynamism, like make alive this shader, right? That's when time variable and sine and cosine enters, and you could just override like the way shaders are like moving. You could use, for example, let's say I want to just move the x-axis like this, and we want to basically move it on the time like this. So it's a little bit like, you see, it's like a slow, you see a little bit, just a little bit, it's like moving. You could just like multiply this by 2. You see, okay, so it's moving a little bit. Let's say I have to change to 5. Okay, it's something like now we go to somewhere. It's moving, like this cyclic moving of the cosine function in nature. So if you want to like, okay, I need to speed up this a little bit. So, we just multiply here by factor of 3. Okay, it's kind of moving. So yeah, that's the basic idea of the vertex. In this case, we are just manipulating or modifying the x-axis of the vertices in this case, and yeah, just in a pace of this amount of time, multiplied by 3, the factor 3, and obviously the factor of the amplitude of 5. Let's say I want to add, for example, the y-axis. Okay, we just change here, copy and paste it, and change here with the y-axis like this. Okay, now it's moving the y-axis. If I want to like move it in circles, we just kind of change here, like cosine by sine. Yep, and what we're basically doing is moving every vertices in a circle motion. So that's why you see that all the object is moving in a circle motion. And from here you can like trying to experiment with some basic knowledge and math. You could use like, what happens if I multiply this like the same amount, like square? You have it's like this motion with motion here. Maybe I have to, I need to just modify a little bit here, like this. Cool. So from here you can, it's like basically your sandbox of like using in this case we call it shader. In this case, it's basically your sandbox of experiments, just to be able to move the way you want the object. Okay, but it's a little bit now annoying to trying to change every time this by hand. Okay, I need to obviously need a little bit more customization on the development side. So we can like use an export variable just to be able to see or to manipulate it from the UI. So this we have here the uniform. So uniform is just a way of saying they go, okay, expose this to the UI so that I will be able to manipulate it. Basically, that's just what we should. And we just declare a float. Let's say, okay, let's call it speed. Let's set it up to 3. Yep. By default. the semicolon. So what you have here, okay, now we can use this variable and we set up here, here, and here. So, okay, but where do I set up this variable? Okay, you go to basically the inspector before, and you see now on the shader option, you have this shader parent tab right here. So from here, you can just adjust the speed as you want. So you want 40. Obviously, you set this, obviously you have like the object wiggling all over the place. But yeah, you can just tweak it as you can, as you like. And this approach, you can do it with colors, you can do it with floats, with booleans. So that way you can save this shader, like we use them in another resource. And it's a time saver for just to be able to tweak and experiment with different kind of effects. So for example, I need to maybe the amplitude. Let's say that I need to uniform this float amplitude file like we used to. Yeah, we can just do like this. Oh, let me save this. This is the scene that I haven't saved it. So, semicolon. Yeah, it's picking semicolon. And yeah, that's what you can do. Obviously, if you want to maybe have like a slider on the UI, maybe here you have, okay, you can set up, but it's not ideal. You have maybe you want a slider from the range. Set up range. You can use this hint, this type like hint range. I will basically do is, okay, you have a minimum value, a maximum value, and the step. If you don't want a step, if you want a smooth like step, you just get rid of this coordinate, and yeah, you can set up, okay, I want start from 1 and the speed to from 1 to 5, and set up default by. So if you see here on the Godot, on the spectre, now we have a slider like this. So it's basically one way to manipulate a way faster the variables, just to manipulate. So let's say I want to save this shader. Oh, it's obviously you go here on the spectre and save the current resource as a resource. You could save. You could save it as this. It's just text, but it's obviously the extension, which we see shader. And yeah, you can have a folder dedicated to all the shaders. You can save it right here, like this, and you can. Okay, I will just set up this. Let's say it's a type. Yeah, that way you can. Oh, I need to just modify this a little bit. You can use another shader and apply it to the other objects, and yeah, that's kind of. Can you use this on a normal spatial 3D? Yes, but not obviously not the type. The type will change a little bit because now this is just used for 2D objects. What you need to do here is just change the shader type like to spatial. So let's say new scene, new scene. This time we're using a 3D scene. So let's start with our mesh instance. In this case, obviously nothing happens because you need to go here on the inspector and set up the mesh. You have all the primitives like every other engine or every other 3D like modeling software. You just add a cube position the cube. Oh, it's a little big, but yeah, we have the cube. And let's say I want to like construct a shader to move the vertices. Okay, let's add the material. We have spatial material instead shader. No, spatial this shader material. So shader material. So from here, and your shader. And yeah, there. As usual, the first line you need to type is shader type spatial. In this case, because why? Because this is a 3D node, so that's why you need to set it up as spatial. But you have access, as I said, you have access to the same processor function, and yeah, you can use like to manipulate the. Let's say I want to like do that there just to swing back and forth on the x-axis, the vertices. So say we have vertex dot y, and that depends on the cosine of time multiplied by multiplier here by 2. Yes, and yeah, maybe. Let's keep it that way, just to see what's happening. You see, obviously, the vertex is like back and forth, and you can always have the x-axis always like this. Okay. I think it got bugged. So, oh, I lost the mesh. Oh, yeah. But yeah, I have like always prepared. I have this like it was a cube before, but you can always change the mesh. In this case, for example, I have an example here, but you can always set like the new cube, like this. So how the shader looks is obviously like this. Yeah, I just added a little bit more like, say, just variability. Just added the vertex x on the cosine function and multiply by 1. But yeah, we just tweak it here. There, yeah. You see that obviously the movement is just like just moving those vertices. But what if the mesh has more vertices? No, it's just obviously you can modify them. Here you can go into the mesh and subdivide a little bit more. If you subdivide, you're basically adding more vertices on the object. So see, we can see that it's like a lot smoother on the movement. So it's like a snake or something like that, swimming on the border or something like that. So yeah, that's basically what we want to, how you manipulate on 3D. And yeah, you can always, as I said, you can save the shader and using it in another like mesh. Oh, I have a mesh that is not a cube. Okay, maybe I use it like this prism. Oh no, maybe I need to use the in like a sphere, like I said. Obviously here the object is like a lot smoother because it has more subdivisions on the mesh. So that's basically why it looks that way. And you can always manipulate them as you wish. But yeah, that's basically it about vertex shaders, and in this case the processing function. Now we're gonna see that the other one, that is fragment shader. The processing function is used to set up, obviously, if vertex like applied the effect on every vertices. In this case, the fragment shader applies it to every pixel on the object, right? So we have new friends here. You have color, like the built-in variable that we're gonna basically modify it as the output of the object. You will see that in a minute. You have UV. UV is like that parameter, like the parameter that allows you to obviously access the in proportional manner the texture or the pixels in a region of the texture. Obviously, you have texture. In this case, it's just an image, and for 3D albedo, if you guys are familiar with 3D software, obviously albedo is the material that you will always use like in 3D so material in this case. But yeah, so now we're gonna use have the, let's say I want to, no, I will just hide this. Let's say I want to use this as a sprite. No, obviously, no, let's make a new scene because it's in there. No, and we're gonna add it. It looks a little bit dark, but it's just because of the, in this case, the image that I imported. But yeah, as usual, you just set material, you got here, you set shade material, and then set up the new shader. The first thing you need to do is shader type. Like this case is canvas. So now we're gonna use fragment. In this case fragment processor function, like this. So let's make the most boring shader in this case. We just gonna set all the pixels for one color. Just set up like this. I call it vector 4. And yeah, let's say what we want to change all the pixels to one single color. Obviously, remember, this is obviously the red channel, the alpha channel, and the red channel, green channel, and blue channel, and the alpha channel is the last one. Yeah, in this case, we just overriding all in this case, the pixels on the object, on the texture, to just one single like color in this case. And yeah, you can always like manipulate the way, if you want to. No, but I want to like change or have a reference of the actual texture, and from there just to be able to tweak some things. Yeah, but you can do that. Of course, you can do that by accessing the actual, like the current state of the texture. In this case, you can use store the colors of the single pixel that you have original on the sprite. You can just, okay, let's declare a vector 4 like this, and yeah, you can use like obviously let's say pixel color, and from there we just get this function like texture. This basically is a function that you need to understand a bit more, but you obviously what it does is just sample the image like this, like right here, from the actual texture. In this case, the variable access the actual texture that has the sprite, in this case the Leni right here, and the UV. That's this. Oh, yes. Yeah. Okay. Okay. Now you have the colors of every single pixel on the screen. You can just, okay, what if I just override them like this? Obviously, this, if you have this, obviously doesn't do much because you are obviously like overriding the colors, the linear colors on the same color of the output. It just doesn't change anything. But let's say I want to just change, for example, the red with the red like this. See, with the red channel. Oh, that's something. What about if we just add the green samples like this? The green channel. So, and if we add just the blue channel, you have the so you can override only the green channel with just a float, maybe 1.4, and you can always trying to change the color of that, like in this case the texture. So basically you can have fun with shaders if you have a little time, but I just wanted to show you some other example that I made for you. For example, let's see here. Let's say might have a shader that we can just override that. Let's go to the sprite, and yeah, we can use like quick load, another maybe grayscale like this. But this is just a shader that makes everything grayscale. You can use the see the code like this. But I basically doing is just like making a average calculation of the every single pixel divided by 3, and just add them on the vector like this. That's all what I'm saying. And you can always have another like type of shader. Say we want to quick load, maybe you guys pixelation, for example. You have a pixelation effect like this. This is a canvas shader. Yeah, basically you just modifying the color as this, and the UV as you see like here, use like kind of accessing the UV and modifying. So what you doing here is okay, you have the amount, and based on this amount, you can just try to tweak it like this. Yeah, and obviously these parameters that are exposed in the shader param are accessed on the with the script. So if you have like a game when you need to make a transition, you just like manipulate this in animation, and obviously the engine will apply the effect on that. So I have a little more time, but wish I had a little more time. But yeah, that's basically what shaders are in Godot. Fundamentally, shaders are responsible for calculating the vertex and colors. I just see thus far. The possibilities are endless. Obviously, this hour doesn't cut up to show you all the great stuff that you might want to see, but you can always find inspiration, help, deep dive on this. Like I could recommend more this URLs, like this hyperlinks that I left it there. So yeah, you could do a lot more. So that's basically what I wanted to show you. And thank you, and have fun. So questions?
Thank you, Gustavo, for the talk. It was really interesting. So I think that what we can agree is that one, I mean, summarizing, right? One of these shaders is to be able to change position of the particles and things, and the other one is to make corrections on the color, right? So you have
yes,
you can say the position space and the color space.
Exactly. Yes, that's basically the kind of change. Obviously, when you have to set up maybe a whole object move to the other side, it's better just to use transition of the engine, moving the position. But if you want to tweak like the pixels or the vertices on the mesh, right? So that's where shaders are very useful. So you have the limitation of the engine, like moving the old object, but with shaders you might just want to tweak a little bit more further. So that's why shaders are flexible in this case.
Amazing. Gustavo Dominguez was asking if you can share those links. Maybe we can share those in Office later.
Yes, of course. I will just push the I was thinking just pushing like a repo just to make you
Okay,
like experiment with those, and yeah, you can pull it from there.
amazing. Okay, guys, and do you any of you have any questions about the talk? You can. Oh, maybe I have close to the people to open the mic. No, yeah, it was blocked because we were having a lot of people joining with the mics on. Okay, if anybody has any question, I'm Gustavo. You had something to show us, a little surprise of a game, maybe?
Oh, yes. Well, I was working a little like for sometime this like side project I had. No, same. Yeah, let's say this. I have this like a project, a little big project, but it's just basically a kind of endless runner like the Dino Chrome we see on the Chrome application. So here, basically, just wanted to do a like old school runner with Leni. In this case, wanted to make just to be able to. Let's see if I have. Obviously, you have here like let's say, yeah, let's see if I can just show them this.
It's amazing.
So I used like shaders in this case, and some like that affect the way we see the screen. In this case, this is like a scanline shader that adds like a filter on the screen that seems like a scanline from an old TV, like this. Obviously, you can just tweak them, like here on the shader. You can add more scan lines or less, or a little bit more, a little bit less, and you will can kind of see different kind of effects. There is another that. Yep.
Those shaders were created by you, Gustavo, or did you find them online?
No, that's the neat part. You don't always have to code this if you at all, because there's a lot of information out there. Obviously, these like shaders are like here on the shaders. You can find a lot of shaders here, like stuff, snippets, and all of that. You can find this. This is the one I use. In this case, you see, it's like add this like kind of effect of an old TV. You can tweak it like this. For example, you have like this in this case. You can tweak the opacity of the scan lines, the width, the resolution that you have. You want to pixelate or not. Like the noise, maybe the static that you need to add, like a static like this. So it's basically what I'm doing. So I also added this intro. It's just a little bit intro maybe for for the Game Boy in this case. Just like this. Oh,
that's crazy.
It's this. This.
That's amazing.
You can always, yeah, this is all made with shaders and lighting effects. So you basically do is like seeing the animation player here. You can see here, you can tweak the velocity. Oh, it's not. So
yeah,
you see, it's all with shaders in this case.
That makes me remember to Flash and ActionScript, right?
Exactly.
Where
yes.
you had
yes.
those kind of layers and you could animate those things. Yeah.
Exactly. Yeah. It's the kind of the same. So it's the ones. If you guys have experience with Flash, this will be a lot easier to implement those animations.
Yeah.
But yeah, that's basically what I wanted to show you guys. How would you like it?
When are we going to have this deployed online so we can play and try
Yes,
to
yes,
best score?
very soon we could just add some like score system like that, like a leaderboard system, and yeah, we could just deploy it with HTML and set up a link for the guys. You guys play it.
Amazing.
Yeah, maybe. Nice.
Okay, guys. Any more questions? Santi was saying that he thought the same thing about Flash.
Yeah, I had some experience on like working and animating with Flash, so it made me like nostalgic from those times, like the timeline, all the screening and stuff. So yeah.
So yeah,
I agree.
Yeah, I exactly. I will recommend you to take a look on the animation player. It has some rough edges, obviously, but yeah, maybe it's so powerful that you might the possibilities of like endless. In this case, you can tweak the easy, you can tweak the time, like the frames. So yeah, you have on your skin, everything got you covered in this case. So,
okay.
any more question, guys? You can ask. Don't be shy.
Okay, if there are no more questions, we will invite you again for, I believe it's the next week, right? Or maybe in 2 weeks. Let me check the dates actually. Yeah, it's actually next week. We are going to be participating in the Global Game Jam. So anybody can join, and you don't have to be an expert in shaders like Gustavo. You just need to have the will to come and learn. Actually, we learn a lot in those 48 hours to be able to create our games. There are a lot of challenges. Even though if you don't know how to code or how to design, there are some other aspects of game creation that can actually be for everybody. And maybe you know how to code, but you don't want because it's you had a rough week or whatever. You can come join us and just chat and maybe throw some ideas for us to code. So yeah, and also test the games, right? That's a big part.
Yep, exactly. Yes.
Okay, thank you, Gustavo. Thanks a lot for the chat, for the talk. I guess that we are going to have more sessions of this regarding Godot and the game engine, since this is the first one of the many talks that you can give about the game engine, right?
Excellent. Yes. Now from now on, I guess if you guys now want to like make or organize some workshop sessions with Godot, yeah, I would love to.
Okay.
To organize it.
Amazing. Thanks, everybody, and see you in 2 weeks, because next week is going to be the happy hour. So see you in 2 weeks. And if you want to join the Global Game Jam, please join us in the game dev community at the game dev channel. And yeah, we can add you to the group and you can participate with us. Thank you.
Excellent. Thank you, guys. Take care. Have a good one.